he wants 6 or more.
It's your fault.
Well, good morning, ladies and gentlemen. Let's see how we did with today's warm-up. What was the system that you wrote? So I got student number 4, 21, 8, and 18. Student number 4, what did you put as the system?
X plus y is greater than 4.
Oh, sorry, 1 second, please. Okay, I apologize. So go ahead again. Student number 4, what'd you put?
X plus y is greater than or equal to 6, and 4x plus 2y is less than or equal to 20.
Okay, student number 21, what did you put?
4x plus 2y less than or equal to 20, and x plus y is greater than or equal to 6.
Okay, so the other two students, hold off for a moment. Sounds like they had the same thing. All right, and number 2, what are some restrictions? So student number 8 and student number 18, and then I'll take any others. Student number 8, what did you put as restrictions?
The restrictions only can be a negative and it can't be more than $20.
Okay, can't be negative, can't be more than $20. Student number 18, what'd you put?
Can't be less than 6 pounds. And you can have half a salad.
Okay. Excuse me again for 1 second. I apologize again for the interruption. So, I'm sorry, Christian, say it one more time.
Can't be less than 6 pounds.
Okay, can't be less than 6 pounds. Okay, very good. Those are restrictions, very good. Now, 2 restrictions are stated in the question. So one of them is this, and the other one is this. Those are 2 restrictions. But they were explicit. They were stated in the question. When I ask you for restrictions, I want those, but I also want the ones that are not written anywhere. The ones that you have to know because you're human and have had experience. So Andrew pointed out one of them. Can't be what, Andrew? Can't be negative. Doesn't make any sense. There's no such thing as negative pounds or negative money in this situation. Now, there was another one that we could actually debate. Did anyone have another restriction that maybe would apply and maybe wouldn't? Melinda? What were you going to say, Mark?
Can I have half a salad?
Okay, so fractions. Now, in this case, I intended there to be no fractions, so I agree with that. However, I could totally see that being debated because here in Florida, if we go to Publix and go to the deli to get something fresh, you can purchase pretty much any quantity that you want. You can buy 3/4 of a pound, half a pound, 1/3 of a pound. You can ask for anything and they will pretty much try to accommodate you. My intention here was buying a large amount of items for a picnic. For a large amount of people, you usually buy things in a big giant tub and they only come in certain quantities. So in this case, I really was going by the pound. If you did not put no fractions or something like whole numbers, that's okay. Don't mark it wrong. It's definitely debatable. Okay? Any comments or questions on what we've discussed here during the warm-up? Anything at all? Okay? So today is 5-6 part 2, so we are not going to pause for homework and getting the scores for homework. That will be done the next time I see you, tomorrow. And we're not going to quite continue where we left off. We're going to refresh what we did, and then take it to the next level. So, here is something that you already saw. And this is just to refresh your memory that when we solve a system of inequalities, solving, in this case, you can't use elimination, substitution, because you're not looking for one point. You're looking for a whole bunch of points. And the whole bunch, the group, the region, is represented by an overlapping area on a graph. And so here, you see the purplish area is the overlapping region. This is shaded once, this is shaded once, this is shaded twice. That represents the set of solutions. You'll also notice that there's white space. That's not shaded at all. In this graph, I have a point labeled. That point is not a solution because it's not within the double shaded region. So this is a solution, this is not a solution, but again, the point is we're looking for a whole region. Okay? So if I relate it back to this, we can't solve this using elimination. We can't do this. We can't say, okay, multiply the whole thing by -4 so that we set that up and then cancel and find the x and y. Because we're not looking for just one ordered pair. So in this case, that doesn't even make sense. So you have to be aware that when we talk about solving a linear system of inequalities, that it has to be a graph. If it's equations, then you can solve it using another method. Is there any questions about that? Good, so let's now explore some other scenarios. And then the biggest idea of the day is to really be able to apply it well to real scenarios like you guys did during the warm-up. So, you may remember, you may not, but the instructions last time for the first example we did was actually exactly the same. Graph the system of linear inequalities, give two ordered pairs that are solutions and two that are not solutions. And you're given a system of inequalities. This is not a checkpoint, but I am going to leave it up to you to graph. But I don't want you to start shading right away. I want you to just get the boundary lines. That's what these, in this case, it's called the boundary lines. I want you to just get the boundary lines down. So in my opinion, that should take 1 to 2 minutes for you guys. So we'll put 2 minutes on the clock and go ahead and get the boundary lines down. Pay attention to your details. What type of line should be drawn? So you should have the boundary lines. And so you should have something that looks like what I have up here. Emily and your team, can you guys see the yellowish line? Okay, thank you. All right, so now, normally I would tell you to shade after doing the first line, then draw the second line, and then shade. But I wanted to do this on purpose this way. So we can pause here and look at the shading. So now we're going to focus on the blue line for you, the line further to the left, and we need to shade. So where are we going to shade for the blue line? Are we going to shade up above the line, or are we going to shade down below the line? Aaron and then Ethan. Ethan, you agree? Okay. So we're going to shade over here. So go ahead, everyone. We're going to work together. We'll go ahead and shade. All right. What about the yellow line that I have for you, the uppermost line, or the one further to the right and up? Which way are we going to shade for that one? We got Milan and then Emily? Above? Okay. So you guys agree that it's going to be above because it says y is greater than. So we're going to go above this line. So now go ahead and shade that in. I am going to give you 1 minute of team talk, and the goal of this team talk is to gather your observations. Anything that you observe, anything that you notice about this graph and this system, any theories that you may develop, any ideas that you have that you think are important. Feel free to share with your teammates and then share with the whole group. So you got 1 minute, which means active discussion about what you are looking at. Go. Gather your thoughts together so that when we share out as a whole group, you can articulate well. Okay, what observations did you come up with? Here we go. I've got team E, B, and A. Team E. Sean, give me an observation that your team came up with.
Oh, that they're parallel lines, so it's gonna be no solution.
They're parallel lines. Are you sure?
That's what they say.
That's what they said.
I'm sure. I'm positive.
You're positive.
I'm positive.
You're positive, and you also said no solution.
Yes.
Okay. Team B, what did you guys come up with, Aaron?
They're parallel, so they're like never gonna cross.
Okay.
So it's like
Okay.
it's just
Okay. Team A, Tatiana, what did your team come up with?
Since there's parallel lines, they're not gonna cross.
Okay. Anything else? We've heard that a couple of times. Any other observations? Okay, so now I'll put it to everybody. Any other observations that you came up with? Deja, Melinda, and then Emily. Deja. Say that again. They have the same slope. Okay, so I said anything on the screen, anything that you see, not just the graph, but the system as well. Very good. Melinda and then Emily. Ah, interesting observation. There's no double shaded area. Emily. They have different intercepts. What do you mean intercept? The y and x intercepts are different. Very good. These are great observations. Very important. Now put it all together. So everybody was right about everything. And there really wasn't any way to get anything wrong there. It was about observing. But first of all, you were right on about the fact that these are parallel lines. So let's start with that. Same slope. Honestly, my expectation for this group, which is probably my top performing group, I would expect that anyone in this room right now would look at that before we even graphed it and you would have known what was going to happen. Maybe you didn't because we're just starting out today, but I think moving forward for the rest of the year, you see something where there's the same slope for two different lines, you immediately should know parallel. Especially since they have different intercepts, as Emily pointed out. Now, Sean, your team said that there's no solution. You guys were the first ones who went. Why do you say there's no solution? Like, isn't this a solution? Speak for yourself, not for your team. Okay, you're not sure? Go ahead, Shannon.
Because there's no solution for both of them. That's just for one of them.
Ah, so this is a solution for just one of them. Okay, I like the way you phrased that. What if I put this over here somewhere? What if I put it right there? That's not a solution? Looks like it should be a solution. It's right in a shaded region. It's right in a shaded region. So why is that not a solution, Kianis?
Because it's only a solution for one of them, not for both.
Okay, so then this must be it right here in the middle. If I put it right there, that's got to be a solution. I don't think they're right. They said there's no solution. That's got to be right there because it's always where, like, they overlapped, right? That's where they overlap, right there. Aaron?
right there where the point is, it's not a solution to any of them.
Oh, it's not a solution to any of them. Yeah, and we made reference to that before, where the white space is not a solution to anything. In one shaded region, that's a solution to one of them. In the other shaded region, that's a solution to the other one. And it goes back to what Melinda said, is there's no double shaded region. So you guys are right. In this case, there is no solution to this system because there's no overlap. There's no overlap. So great observations. Great job. Does anyone have any theories or any new observations? So the second part of the question says, give two ordered pairs that are solutions. What do you have to say about that? Give two ordered pairs that are solutions. What do you have to say about that part of that question? Von Travis, what do you say about that? Give two ordered pairs that are solutions. Okay, so that was a great statement that you read. There are no ordered pairs that are solutions. But then it says two that are not solutions. Can we give two that are not solutions? Could someone make a statement about what we're looking at and that question? Natalie? Why? Okay, So we could say something like any point.
Is
Very good. That was a great way of saying it. So every point on this grid is not a solution. So in this case, where we're asked to say two that are not solutions, you can close your eyes and put your pencil down, and no matter what, you will land on something that's not a solution. So you could say that's not right there, that's not a solution, and 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 no matter where we go, it's not a solution. Does anyone have any comments, concerns, any issues, any theories, any thoughts? Good, we're doing very well so far. So now part B. So you don't need to copy the instructions. This is the third time you're seeing these same instructions. Graph the system of linear inequalities, give two ordered pairs that are solutions, two that are not. So now, I would like to do this, since this is not a checkpoint, this is a learning process, I would like to do this in a couple of different parts, in a couple of different steps. So we have to graph this, and when it comes to inequalities, the best thing to do is to get it into slope-intercept form. So what I would like you to start out with is, I'm going to give you a minute. I don't want you to worry about the actual graph. I want you to just rewrite, get it set up for graphing. So this is individual, not team. Take 1 minute, get it set up for graphing. Should take you 1 minute or less. Some of you put your pencil down and already done. It's been 30 seconds. Think about how 2 months ago that wasn't the case, was it? Think about the complete leap in your confidence in your abilities. That is dramatic. So you should be incredibly proud of yourself, and I am proud of you. If you're still working, it doesn't mean you did anything wrong. It just means that you're taking your time and you're getting it right. So I'll wait till the time stops. And then I'm going to call on a few volunteers to give me what it turns into. Okay. Could someone volunteer and tell me what the first inequality turns into? Isabella. Y is less than 3x plus 6. Give me a thumbs up if you agree with Isabella's rewrite. Good. And what about the second one? What does that turn into when you rewrite it? Sean?
Y is greater than 3x minus 2.
Y is greater than 3x minus 2. Give me a thumbs up if you agree. Okay, so just about everybody agrees. Good. So now this is a system. We're now putting them together. Okay? Observations. We haven't even graphed yet. Any observations that you have about what you're seeing now? Well, we got a whole bunch of people who have observations. Tristan, and then we'll go to Daniela. Tristan, observations. Same slope. They're going to be parallel. You feel confident about that? You feel confident? Okay, so we already have an instinct. We know we have a good, we now have a good idea that they're going to be parallel. But remember that these are inequalities, and so now we have to pay attention to the shading. The first question, I asked you to just do the boundary lines and hold off on the shading. This time, I would like you to do the whole graph. Do the boundary lines and the shading on your own. You may consult with your teammates or with me at any point. This is part of the learning process. So I'm going to put 3 minutes on the clock. I think 3 minutes is enough time, considering how well developed your abilities have become. time, just get up and go. Okay, whether you're done or not doesn't matter. This is not a checkpoint. This is not a gotcha moment. This is part of the learning process. I just wanted you to do the work on your own because I know you guys can. So if you just pause for a moment and come back together as a whole group. Some of you have finished or mostly finished. Now, I did the boundary lines, but I did not do the shading, and I did that on purpose. After the last example, I asked you guys for observations, and I called on this group here. And Sean first said, the lines are parallel, there's no solution. He said it almost as one statement, lines are parallel, no solution. Which is true if there's equations. Last example, that was true. What about now? Lines are parallel, do we say the second half of it? What do you observe about your own graph? What do you observe, Kianis?
That they are going to have a solution.
They are? Why?
Because when you shade them, they're going to overlap.
They are? Okay. So let's look at my blue line, which is this right here. Which way do I shade? And some of you are going to kick yourselves, by the way. Which way do I shade, Von Travis? I'm going to shade down, which in this case means start here and go this way. So unfortunately, some of you shaded in the wrong spot, but I want you to watch. So we're going to shade over here, and I'm going to go like this and shade in this whole thing. Okay? Now my yellow line here represents this right here. Which way are we going to shade that one? Where am I going to shade? Von Travis, you're on a roll. Keep going. I'm going to shade up, which means if I was standing right there like a mountaineer, I would go up from there. And so now I'm going to shade here. So Melinda, after the last example, was the student who first articulated that the regions didn't overlap. She said there's no double shaded area. Melinda, what do you have to say this time? There is. Where is it? Okay, I like the way you use that word. Between the two parallel lines now became the shaded area. Okay? So now, does anyone have any questions or comments about what happened? I noticed some of you shaded in the wrong spot for some of it, but it's part of the learning process. You get better at it. So now, the second half of the question says give two ordered pairs that are solutions and two that are not solutions. So I'm going to give you a minute to work as a team, and I want you as a team to come up with two solutions, two non-solutions, and any other observations about what we're looking at. Two solutions, two non-solutions, and any observations. You got 1 minute. Go.
This line, this shape goes down. This one goes down. So we change between them. So it has to be changed. Yeah, it has to both have to be crossed or
Is this supposed to be the solution area? So what I want you to do is get used to now shading that a little bit darker because you want to be able to instantly tell. All right. So solutions. Let's start with solutions. Let's go around solutions. We'll start with Tatiana, Emily, Von Travius, Mark. Tatiana. 0, 0 is a solution. 0, 3. 0, 1.
-1, 1.
-1, 1. Very good. So anywhere inside the double shaded region is going to be a solution. I heard some people debating this point right here. Anyone have any thoughts on that point? Is that a solution? Here, let me mark it down so you can see it. But that's not, I don't know if it is or not. What do you think? Ethan, what do you think?
It's not because it's on the diagram.
You think it's not. Do you agree with that? There was other people who had their hands up. Do you agree with that, Aaron? You agree? Yeah, that's not a solution because the line is dotted, and that specific line constitutes points that are not solutions. So unfortunately, that would not be included. Okay? Good. Excellent job and very nicely articulated. All right, non-solutions. Non-solutions. We'll go Christian, Angela, Kianis, and Andasia. 3, 1 right there. Angela? 2, -1. -3, 5. 1, 2, 3, 4, 5. Beautiful. And who was Kian?
3,
3, 3. Beautiful. I love how someone chose one in this region and someone chose this region. Any comments or questions about non-solutions? All right, any observations that you have? Anything that you noticed about this graph compared with the last one? We have observations. Mark, Aaron, go.
Well, the equation, like the linear system, is parallel, but even though it's parallel, since the inequality symbols, like one is less than, one is greater than, the line on the right is going up, but it's going to be be shaded up since it's greater than the line on the right is less than, so it's gonna be shaded down. There'll be like there's gonna be like side to side, and one's going up, one's going down.
Okay. Good. Okay. Good. Aaron, you were next, and then Montravius.
Is that shading across?
Okay, so the shaded parts do overlap in this one, compared with this one here, where they didn't overlap. But I want you to look at Mark's observation, because it's an important one, but you got to be careful. So he's pointing this out, but they were opposite. They're pointing in opposite directions. He was trying to do something like this, but in this case, they don't overlap. These point in opposite directions, but they do overlap. So it's about which way they're pointing has an impact, okay? Any other observations? Any other observations? Von Travis, you were waiting? Same thing, okay. Nothing else? All right. Now is the time for you to demonstrate that you are starting to understand. Checkpoint number 1, graph the system. Give me 2 ordered pairs that are solutions, then 2 that are not.
do that every time you're going. It's just wow. I'm barely. So this one here is this one, right? Yeah, so since I know the room, I went down this way. So I went okay, down 4, 1, 2, 3, 4, 4. So I did that. So greater than, so I'm shading everything over here. This, the bottom one, is like that. So they will shade it. And this would be the solution. This would be
All right. This is not really a situation where I can call on volunteers. So this is what your graph should have looked similar to. I borrowed this from the publisher, so let me explain. One was a solid line shaded blue above. One was a solid line shaded red above. And where red and blue overlap becomes purple. So this region here is the solution region for the system. You were asked to provide two solutions and two ordered pairs that were not solutions. Any point over here, and my grid is not not evident, but any point over here would be a solution. Any point within this shaded region and any point out here would not be a solution. So just check and make sure that you have ordered pairs that are within the purple shaded region and non-solutions were the ones outside. Any comments, questions? Any observations? Any theories? Yeah, and so that goes back to what Mark was trying to articulate, which was that these two are actually pointing in the same direction. And look at what happened. Is we shaded up, and then we shaded up again, and instead of the inside, in between, like one of your classmates said, one side of the parallel lines becomes the overlap region. What if they were both pointing the other direction? What do you think would have happened? If these were both like this, if this was that way and that was that way, what do you think would have changed in the graph? Give me a thumbs up when you've got it in your head of how you think it would change. Gloria, what's your thought? Yeah. So where? So you said purple, and that would transfer to where? Okay, and what color is that area now? White. So the purple would transfer to the white. Okay, Daniela, do you agree with that? You think it would just switch? Okay, Montraves? The blue would turn into, say it again? Because I said, and it's a little, you can see it a little bit here, that the color that was used to paint up here, shade up here, was red. That would now flip down this way. Interesting point. Very good. Mark?
I have a question. I think, and I kind of answered myself, but if it's -1 and 2, it's still a solution, right?
-1, 2. I can't see the grid, but it looks like it falls on the line, so I think that would be a solution because it's a solid line. Very good. All right. Any other comments, any questions, any observations? So we started out just graphing any old system, and we saw what happened there. Then today we saw parallel lines, and we saw 3 different cases. We saw parallel lines for which there was no solution. We saw parallel lines where the solution region was in between. and we saw parallel lines where the solution region was on one side of the parallel lines. So now we're going to go to the most important aspect, which is applying it to a real scenario. I do not need you to copy the text of the question. I need you to read the text of the question. Of course, write example 2, and then read the text of the question. All right, so we're going to do this in little parts, and it is going to be a bit of a process, and so your perseverance is going to come into play. But you guys are doing really well today, so I don't think that's going to be an issue. So I am going to leave the first part up to you, which is to come up with the system. So I've already kind of given you a hint. It doesn't say anywhere in here that it's a system, but I think some of you maybe already knew, and I wanted to give you a hint. So you're going to come up with a system, and I want you to come to an agreement with your teammates on what the system should be. So take 2 minutes to just come up with the system. Don't do anything beyond that. Make sure you write it down.
Plus R.
All right, let's see what you came up with. I got team C, F, B, and A. Team C. Daniela, what did your team come up with?
20x plus 10y is greater than 125.
Hold on, 20x plus 10y is what?
Greater than 125.
Greater than 125, okay.
And then the other one is 9x plus 7y is
Less than what? 7, okay. Good. Any other proposals? And we'll just take as many as we need, and we'll just try to figure if we can put them together. So, Team F.
20x plus 10y is greater than 125.
Okay, so we have an agreement here, okay? Did you come up with a second one?
Yeah, 9 plus 7 is less
9 plus 7 is less than
than 7.
7, okay? Team B. Natalie, what did you guys come up with?
20x plus 10y is greater than 125.
Okay?
And then 9x plus 7y is greater than 7.
9x plus 7y is less than 7, okay? And Team A, what did you come up with, Milan?
20x plus 10y is greater than 125.
Okay, so we have yet another agreement, 4 agreements for that first one.
And then 9x plus 7y is less than 7.
Really? So all of you got that? You had that? You guys wrote that down before anyone else said that? That's interesting. Okay, because that was really hard to figure out. Okay, Mark, you wanted to add something? Go ahead.
Yeah, because like I was thinking to myself because they don't understand my thinking, but I did f or x plus y is less than or greater, or like no, less than or equal to 16.
Okay, x plus y is less than or equal to 16.
Yeah.
Okay, good.
They know the law.
Okay, so any thoughts? So we have a lot of people who agree on this first one, so I'll buy into that that is definitely going to be part of the system. But when we did this first one, we defined what x and y represent. So could someone tell us, based on this, and we're going to say that that's correct, what is x now representing? What's x representing? Angela? Mowing. Could you add some words to that to make it more clear? Is it the cost of mowing? Is it the temperature of mowing? Is it...
How many times?
Okay, so it's the number of times that he will go mowing. Very good. And what about the y? What is the y representing now that we've defined it by putting it in there? Deja? Very good. So it's the number of times that he rakes. Now look at the second inequality. 9 times the number of times he mows plus 7 times the number of times he rakes must be less than 7. So that means if he mows 1 time, right? We put a 1 right here. 9 times 1 is 9 plus anything, even if it's 0, will that ever be less than 7? Okay, so there are some huge issues with this second one, and I was actually a little confused. I didn't know if some of you were just repeating what someone else said because you thought maybe you just would get off the hook. But yeah, this really doesn't make any sense at all. How could you have 9 times something that has to be a whole number be less than a number less than it? Doesn't really make sense. Now let's look at the third one. 9 plus 7 is less than 7. Will that ever be true?
No.
Okay, so that's... And so, to be honest with you, I'm surprised that more people didn't say the last one, because that's what I expected. I expected more people to say the last one, however, there's issues with that as well. And so now, here's where we start getting into the difference between regular algebra in 10th grade or 9th grade and algebra 1 honors in 7th or 8th grade. Is that this is higher level thinking. And so this is part of the expectations that I have of you and the state has of you. Is that x plus y is less than or equal to 16 is what I would have expected, because there is some similarity between that and today's warm-up. And look at what many of you got for today's warm-up. But there is a major difference. And it actually has to do with the English language. It doesn't have to do with math. So I want you to look here. It says macaroni salad, potato salad, but then all of a sudden it says at least 6 pounds of salads. So it started with macaroni, potato, and then all of a sudden what happened? What happened with this one word right here? Something in the English language happened.
There
They put them together. They lumped it together as one category. So, yes, we are saying X is macaroni salad and Y is potato salad, but then the English language allowed us to put it together as salads altogether has to be more than 6. So we were allowed to use one number because we lumped them together. Now look at what happened in this question. Let's put it this way, Christian. If we wanted to take the word mow and rake and lump them together with a category name, what word could we use to describe them? Oh, I love that. Yard work. Very good. What was your thought? Landscaping, okay. Jobs would also, because this is a person who's doing this work to make money. But I love how you said yard work. So that's a higher level category that covers mowing and raking. Did any of those terms come up? Does it say he could only work 16 jobs? Or he has to work less than 16 jobs? Or less than 16 times of yard work? Doesn't say anything like that. So at no point did it combine it. Let me put it to you a slightly different way. Let's pretend that this is correct. I would like someone to pick a large number and a small number that equals 16. Large number and a small number that equals 16. Can someone give it to me? Large number and a small number that equals 16. You can't do that? I should see every single hand flapping in the air like, oh, I can do that, Mr. Gallup. Shannon?
1 and 15.
Okay, so let's pretend that Ed mows 15 times and rakes 1 time. Is this a true statement? Yes, it is. But now, look at the English. Does it meet the requirements?
No.
Someone tell me what's wrong. What is wrong? What's wrong, Von Trevis?
You can't have 15 because
That's right. This is a restriction. And we broke the restriction. It still worked in this, but it doesn't work because it actually doesn't work with the scenario. Which means that this must not work. Because we got it to be true, but it actually breaks the rules. So, excuse me. So x plus y is less than or equal to 16 won't work. It worked in the warm-up today, but it won't work here. Because there are 2 restrictions being put, and they are separate. And then there's a 3rd restriction here, the $20, $10, and make more than $125. So now instead of 2 restrictions, we have 3. And so I would never expect any of my classes, even though they are Algebra 1 honors, I would never have expected any of my classes to figure out what this was supposed to be because you don't have enough experience to lead you to it. But now you will. What would you write to represent just this? How would you represent, oh, I'm sorry, I forgot one. You got it all right there. What would we write? I did warn you it was a bit of a process this first time, but now we're at the critical point. Emily? What? So we need that. What's going to go right there? What's going to go right there, Isabella? X, and that's it. X must be less than or equal to 9 because mowing is now X because of this. X must be less than or equal to 9. So now what's the other restriction? What's the other statement going to be? Now you should easily be able to piece it together. Kianis?
Y is less than or equal to 7.
Y must be less than or equal to 7. And for the first time this year, you are seeing a system that is made up of 3 statements instead of 2. And a system can be made up of many. You just are limited usually in Algebra 1 Honors to 2 or 3, and this is the first time you're seeing 3. Any questions about that?
Okay, so like I had that, like I thought that, but then like you couldn't do 2 in the system. Like I didn't know you were allowed.
Okay,
to.
so that's what I said is you didn't have enough experience to say, oh, I'm allowed to do this. So I understand that, absolutely.
How would you graph?
We're going to do that right now. You already know how to because we did it. Actually, I don't think we got to it last time. So we're going to do it right now. Now, each one of these statements is putting restrictions, but there are also some other restrictions that are not written down. What are some of the other restrictions about a scenario in which someone is mowing, raking, and trying to make money? Mowing, raking, and trying to make money. Natalie?
You can't have negatives.
Can't have negatives. What else? Isabel? Can't have fractions because you can't mow half the time. You could, but then you'd get fired. So we need just quadrant 1 and we need whole numbers, okay? So let's go ahead and get this set up with just quadrant 1, and I'm going to leave myself a little bit of space next to it. But we don't know what the scale should be because the first inequality is written in a form that doesn't help us very much. So we need to rewrite this into a form that helps us graph. So before we graph and before we label the axes, we need to get that set up. That's, for some of you now, a 30-second process. For some others, it's a minute. So take a minute to do that, and then we're going to come back, set it up, and graph. Again, I understand it's a long process, but just this first time. After this, you will start to get used to it. Get that set up in a way that we can graph. So I'm asking you to rewrite the first inequality. You can do it on your own. You don't need me. That's not the end of time, that's just getting it rewritten. So what does it come out to when you rewrite it? Where are my confident students who do that in 30 seconds? 1, 2, 3, 4. Only 4 people were able to do it? We're exhausted now. Melinda?
Y is greater than negative 2x plus 12.
That's it. That was critical. That right there, doing that, now tells us how to set up the grid. Now I know if I can go by ones or not. Let me count, make sure I can. Do I have enough room? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Absolutely, I got plenty of space. You should too. And the slope is nice, negative 2 over 1. So that'll be easy. So we're just going to go by 1. So that's 0. 1, 2, 3, 4. And go by 1s going on the x-axis. And here's the key. The key piece for interpretation is labeling your axis. And so we had 2 of your classmates who helped us see that x was mowing and y was raking, so this is the number of times mowing, and this is the number of times raking. And so what we can do is find ordered pairs that are combinations that will meet the restrictions. So we are already comfortable graphing y greater than negative 2x plus 12.5. So let's go ahead and start with what we're comfortable with, and then we'll move to the parts that you're supposed to know, but I understand you're less comfortable with. So 12.5 is the y-intercept, so you're going to have to estimate a little bit, but you should be able to do a good job. And now we go down 2. Make sure you go down 2 from there. So you're going to end up another halfway there. Oops, I'm sorry, and go over 1. Right there. And now draw a nice, clear line, paying attention to what type of line it needs to be. And in this case, you don't need arrows because it's not going on and on forever. And then we need to shade. Did you shade already? Shade lightly. Shade very, very light. So this shaded area, this giant shaded area, we can now actually interpret just that. Every combination in this area will earn Ed more than $125. Every combination, this combination, this combination, this combination out here, every single combination here will earn him more than $125. However, we have other restrictions. In other words, he's not allowed to work as much as he wants. He can't just work, well, I don't know what this is, 13, 14, 15, 16, 17, 18, 19, 20, 20, 20. He can't work 20 mowing jobs and 20 raking jobs. He's not allowed to because we have these other restrictions here. So now we have to put those into the graph. So let's start with this right here. X is less than or equal to 9. How do we graph x equals something? How do we graph x equals something? And it says x is less than or equal to something, but I'm not talking about intercepts. I'm not saying the x-intercept is 9. I'm saying x equals 9. How do we graph that? So this is the response I get from most of my classes. And so we have to reach back to something you learned that we didn't spend a lot of time on, but you're supposed to know. X equals negative 3, x equals 4, x equals 1/2, x equals 1,000. These will all look the same. What will they all look like? Ethan? Close. You're in the ballpark, but you messed up and you got fired, but that's okay. It's not really a job yet. Tristan? Yeah, these are all going to be vertical lines. These are all vertical lines. You graph them very simply. You go on the x-axis, you go to the 9, you put a point, and you draw a vertical line. So that's your starting point. And now we're going to draw a vertical line, and it's going to be solid because of the symbol. And so this gets drawn, and now we have to shade. So now this is something new. Where do we shade? Where do we shade? x is less than 9? I've never seen that before. Which way do you think we shade? Here's the boundary line. Do we shade on this side of it or do we shade on this side of it? What would make sense? Some light bulbs went off for some people. What would make sense? Milan?
Shade
To the
left.
yeah, because it says x is less than. If I was standing right here and I asked you to go less than, well, these numbers are less than. So this is going to get shaded to the left. And watch what happens. Now we've added in one of the restrictions. So now we can interpret it even further. Everything that was green constituted a combination that would earn him more than $125. But now this restriction means that only points in here, this point right there, and that point right there, that one there, and that one there, and this one down here, and that one there, all of those points will earn him $125, but will also make it so that he is mowing 9 times or less. So he can make more than $125 mowing 9 times or less. So, but now we have yet a third restriction. Y is less than or equal to 7. What do you think y is less than or equal to 7 is going to look like? What do you think it's going to look like, Deja? Horizontal line. And so it's quite simple. Shade. What happened to my shading? What did I do? Sorry about that. So now we add in the third piece, and let me pick a good color that will overlap well. I don't know if it's going to work, but we'll try. So now we go on to the y-axis, put a point at the 7, and draw a horizontal line. It's going to be solid. And now we need to shade. Which way are we going to shade this time? Which way are we going to shade this time? Emily? We're going to shade down. And so watch what happens. Oops, my fault. So now all of the restrictions have been applied, and so now you unfortunately just have pencils for most of you at your disposal. Now you need to find the region that wasn't shaded twice, the region that's shaded 3 times. And so the whole graph is shaded now. There's no white space anywhere. This is shaded once. This is shaded twice. This is shaded twice. This is shaded once, this is shaded twice. It is in here that everything is shaded 3 times. And so every whole number ordered pair in this region, every ordered pair in this region constitutes a solution to this system. Everything in here. Could be on this line because it's a solid line. Could be on this line because it's a solid line. Every single one of those points constitutes a combination. And so we're asked, lastly, to list 2 possible combinations. You can pick any 2 points that's in that region. So that was a long process. That took us 10 minutes to get through that, and I understand that's tiring and it's at the end of the class. I get that. Okay? Are there any comments or concerns, any observations, any thoughts? So I did have planned other questions, but I understand that it's just time's not going to work out. But you now have enough experience, like Mark said earlier, he thought something like this was going to happen, but he dismissed it because he never saw anything and no one ever told him, I never told you, that you could have more than 2 equations or inequalities. But now you know. Also, you need to be aware of when things can be lumped together and when they can't be. And it's all based on English, and like Christian was able to take two ideas and lump them together by using the term yard work, you want to look for things like that. In this example, you could not lump them together, whereas in today's warm-up, we were able to lump them together because it was done for us right here. So, does anyone have any comments, questions, any concerns of any kind? Good. So, draw a line across your paper. Your homework is on page 311. It's the same assignment you already got. Page 311, numbers 1 through 7. You now have enough experience to do all of it. That's a total of 16 questions because each part counts separately. Did I already show you how that worked?
Yeah.
Okay. And your test will be, I see you, perfect. On Monday will be chapter 5.